All right. So good day, Grayton. So this video, we're going to discuss a new topic, which is second type of connect section that we have, So, but before anything else, let's have this short opening prayer as usual. So let's bow our heads and feel the presence of the Lord in the name of the Father, the Son, the Holy Spirit. Amen. Lord, we offer you everything we do today. All our works, our joys, and our sorrows. Everything will be an act of love for you. Holy Mary, Saint Joseph, Saint Joaquin, and Saint Anne, and Guardian Angel, intercede for me so that I may be deserved to be helped and saved today and always. Virgen del Pilar, pray for us. In the name of the Father, the Son, the Holy Spirit. Amen. So, once again, good day, grade 10. So, we are going to discuss a new topic, which is a part of the conic section, no? Which is the ellipse. No? So, we are going to discuss in this video about the ellipse. Now, some of you may know this already, but for those students who weren't able to have this lesson still, and for those students who want this recorded video as the reference, no? So here's what is an ellipse is, no? So ellipse is a set of points in a plane whose distance from two fixed points is a constant. So from your two cones, no, when you have a plane intersected in that cone, having the horizontal manner, no, it forms circles, ellipse, parabolas, and hyperbola. So it differs with the it differs, no, the the connect section differs based from uh, based on how the plane are being intersected in the cones po. Alright? Sige po. So, but this time we're going to talk about an ellipse, no? So, if we say ellipse, no, by definition, what is an ellipse? Ellipse is a closed curve that can be represented by the equation. Of course, we cannot have ellipse if we don't have equation for it. No, just like the circle, a circle have an equation, of course. So we cannot have a circle if we don't have equation. And without equation, you couldn't have the coordinates of the center, the radius, as well as for the ellipse. No, so if we have the center and the radius for circle, so that those are the parts of the circle. So in ellipse, there are parts also for this ellipse. No, so ellipse has parts as well. So what are the parts of ellipse? No, so ellipse has foci, vertices, major axis, minor axis, principal axis, conjugate axis, and intercept. So as you will notice, there is letters right beside the foci, vertices, and intercepts. And maybe some of you will tell me that mentioning this word is wrong. So to tell you, there are um, different pronunciation about this word. No, some other words differs. Some of the pronunciation about this word differs depending on the country because there are some, for example, in British it is called it is read as I remember it is read as foci, foci, no, but some of the other country uh, it what was this one? It reads. We read. They read it as a foci. Some other country is reading. Is telling this one as foci, 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 foci. So, but in our class, we're going to tell it as, we're going to read it as a foci. No? So we're going to say it as foci. So these are the parts of an ellipse, no? And as I mentioned a while ago, these letters represent something. So what are these letters? No? So we are going to tell it what are those letters. No? Alright, so starting with the first part of the ellipse, we have the foci. So what are foci? Foci are the two reference point of the ellipse that helps us in drawing the ellipse. So this foci is one of the big factor, and it is one of the components that helps us to locate and draw our figure ellipse. No? So, ellipse, this foci in ellipse, it is a two reference point. Please take note of that one. So, if you say two reference points, therefore, uh, our one reference point is called as focus. So, if you have two reference point for your ellipse, that is called as foci. But if you have one reference point, that is what we call as focus. Alright, so please take note as well that foci also lies in major axis. Okay? Major axis of the ellipse. Later on, we're going to talk about what is major axis. And please take note that the two reference points are equidistant from the origin. Okay, they are equidistant from the origin or the center of the ellipse. Okay, and please take note that ellipse represents the locus of a point. Okay, if you say locus, what is the locus? That are the points that these are the points outside of the ellipse. Okay, so in circle, the circumference, that is also in locus or circumference just used in the measurements, isn't it? Okay, but locus represent the points, no, that has the distance from that point. These are the points that has the distance, equal distance from your point. So if you have the two reference point and you have the locus, okay, locus represents the points, okay, which distance of these points are fixed and has the constant value. So whatever the distance of these two reference point, the totality, for example, this is your point 1, okay, point 1, and this is your point 2. When you add them both, the sum the sum of point 1 and point 2 are always equal wherever your locus will be located. For example, this is the point, point 1. This is your focus 1. This is your focus 2. Okay? So, P1 and P2 are just equal. Why? Because whatever the sum of focus 1, just take note na, the magnitude. If you say magnitude, the distance, no? From your P2, P2, F1 plus, this is a segment plus the magnitude of P2, F2, it is equal to 2A. Please take note of that one. So therefore, even though your P1 and your focus 1, the magnitude of your P1 and focus 1, when you add the segment of P2 and focus 2, okay, when you add the segment coming from your point 1 to focus 1 and point 1 as well, I'm sorry, point 1 to focus 2, no? When you add that one, it is also 2A. So, what it means, whatever the sum of the points, for example, this is the point 3. Point 3 is also 2A. Okay? So it means locus are the points has are the points that has the constant value. If you say constant, it doesn't change. So it means that constant value surrounds the focuses or our foci. So that is our two reference points. That's why I'm telling that the two reference points are really important in a major part of the ellipse. Okay? Sige po. So please take note ha. Those are foci and the magnitudes. Alright. Next, or for example, I have this picture of a uh, what do you call this one? Tie, no? Okay, so we have this one. It represents our ellipse. And these two fingers represents as the focuses. Okay, so it represents our focuses. Now, from our ellipse, as we said a while ago, uh, foci lies on the major axis. So here's our major axis, and they are equidistant from the center. This is our center. So whatever the measure of your focus, coming from the center to your focus, that is equal to the other side as well. Okay? Now, please take note ha. Okay. So next part, we have the vertices. Now, from the vertices, the vertices of ellipse is the point of intersection of the ellipse with its axis, no? Point of the intersection of the ellipse with its axis of symmetry. If you say axis of symmetry, those are the major and minor axis. So we are going to talk about what are major and minor axis, ha? If we say axis of symmetry, that's the axis that we are basing with. Okay? Okay. So, if we say vertex, that is the point where it intersects the axis of symmetry. So, therefore, if this is your ellipse, okay, so if this is your ellipse, this is it, Alright, so if this is your ellipse, your point intersects your point. If this, isn't it that we talked about a while ago, the locus? It's a consist of points. So if your point intersects with the axis of symmetry is your major axis. So if it intersects with the axis of symmetry, those are the vertices. So therefore, all the points that intersects with your axis of symmetry is your vertices. Okay, it is called as vertices. Not some of the pronunciation it is called as vertices. Okay, so let's call it as vertices. If you have two vertex, it is called as vertices. If you only have one point that intersects into ellipse, that is what we call vertex. Okay, so this is vertex 1, and this is our vertex 2. Or we could just tell it as vertex or vertices. Okay? Alright. So same goes by a while ago. If you have this figure, this is your focus. Alright. So your vertices is in here. Okay? So our foci lies on the major axis or the axis of symmetry. So therefore, you could found the vertices with the foci along the major axis. Now, as we mentioned a while ago, the axis of symmetry, we have major and minor axis. So, an ellipse has two axes of symmetry. What are those? We have major axis and minor axis. The longer one is called as the major axis. Ha. So major axis is the longer axis that we could found inside the uh, ellipse. So in ellipse, if this is your ellipse, in ellipse, the parts of ellipse, isn't it? We have the foci, we have the vertices, we have the major axis, minor axis. In ellipse, it always represented that inside of the ellipse there is axis, no? Even though if this is your Cartesian plane, even though it is your Cartesian plane, this is your origin, isn't it? Your ellipse could be placed in here. Okay, you have the axis inside of it. But sometimes there are ellipse that could be found not in the origin. So, as well, as I said a while ago, ellipse has its own axis inside of it. Okay, so therefore, we have the major axis and minor axis inside that ellipse. And the longer axis is what we called major axis. Okay, and our shorter axis is what we call as minor. Okay, minor. All right, so I hope that it is clear enough. All right, so the two axes intersects at the center of the ellipse. This center performs a perpendicular form. Okay. Alright, so when the length of the major axis is the same as minor axis, oh, of course, if this is your ellipse, of course there is the longer one and there is a shorter one. But what if your axis or the major axis becomes equal, comes with the equal distance, no, of your minor axis? What if they are just the same? So, of course, they will just become a circle. Okay? So, if they have the same length, it will become as a circle. Okay? Alright po. So, those are for axis of symmetry. So, how about the principal axis, conjugate axis, and co-vertices or intercepts? No? So, if we say principal axis, this is where we are basing with. So, later on, you could understand what our principal axis are. And if you say conjugate, from the word conjugate, this is the other axis, no, that we are not basing with. Okay? Then, if we say intercepts or co-vertices, if you have vertices vertices could be found on the axis of symmetry or major axis. Major axis. So, means if you have co-vertices, you could found co-vertices at the minor axis. Okay? And we could call it as intercepts as well. Okay? So, we have the letter of B. So, uh in your what do you call this one? In your intercepts, no, or in your co-vertices, let's call it co-vertices, you have the value of B from your center, So coming the segment coming from your center up until to your co-vertices, the value is B. Same goes by to the other one, why is it negative? Because you decrease it, no? So later on you will understand. Or let's just say B. So for your vertices, we represent it with A. Okay? We represent it with A. So therefore, coming from your center up until your vertices, the value of it is A. Same goes by with the other side. Okay? So therefore, if you're going to get the distance between your first co-vertices to the other co-vertices, the value of it will be where you are just going to add the distance of this co-vertices as well as for this one. You're going to add, so you will have 2b, isn't it? Alright, so as well as for your co-vertices, your vertices, I'm sorry, so vertices. So therefore, your CV first is 2b. Your vertices now is equal to 2a. Let's have this. No, not covered. Let's just tell that the segment for your minor axis, minor, this is your major. Okay. Alright. So this is your minor and this is your major. Alright. So we could tell that your major axis is equal to 2a and your major axis is equal as well for the locus a while ago. Okay? Alright. So what is our focus? Our focus represented with what? It is represented with letter C. So if this is your focus, this is your focus. Isn't it? The focus lies on your major axis. Your C and C. So what are the values that you have? You have letter A, B, and C. Okay? Alright. So, let's just figure what is, or let's just try to figure out what is principal axis and conjugate axis are. Alright, so let's have this ellipse. Okay, from the major axis, which is our major axis? Isn't it that you have a mini Cartesian plane inside the ellipse? You have the we have the x-axis and you have the y-axis inside of it, isn't it? Now, your major axis, if your ellipse lies in this formation or in a horizontal manner, your principal axis will be x. Okay? Because the Cartesian plane, when your ellipse, the Cartesian plane inside your ellipse is the longer one. If the longer one is x, therefore your principal axis is x. And if your ellipse, when your ellipse is represented in a vertical manner, inside the ellipse it has own Cartesian plane. If y is the longer one, or y is your major axis, so therefore your principal axis is 1. Alright? So that is how we identify what is the principal axis and conjugate. Or if we say conjugate, that is the other way, or that is the other axis that we have. Alright? So this is our conjugate axis. Alright, so why are we telling this principal axis and such? No, so if you will remember in circle, there is two formulas. When the center of your circle is in the origin, you have that first formula. Then your second formula, when the center of your circle is not in the origin, or for example, if you have the Cartesian plane, the circle is uh, placed in this part of your Cartesian plane. So your circle lies on the first quadrant. Oh. The center has the value of h and k. So as well as for the ellipse, we have that kind of scenario when the ellipse is at the origin and when the ellipse is not in the origin. So therefore there is h and k. But there is a twist, no? A bit twist uh on this ellipse because circle has the equal distance coming from the center up until to the radius. But in ellipse, it has two vertices. Or the radius that they don't have radius because radius is for circle. We have this what we call vertices and co-vertices. So those are the sides, isn't it? These are the sides. So we have two cases in here. So we have two cases when this let's just say first when when the center of your ellipse is at the origin, you have two cases. When the principal axis is x-axis and when the principal axis is at the y-axis. So let's focus first when your principal axis is your x-axis. Okay, so here is the formula. So if you will notice, this is uh, this bit same from your circle, isn't it? So the formula in circle, you have r squared is equal to x squared plus y squared, isn't it? Or sometimes r squared is equal to x minus h squared plus y minus k squared, isn't it? So same goes by in here. That is just that there is denominator. So this is the standard form for the ellipse when the principal axis is x. Oh, why is it principal axis? What are your parts? You have the center, you have the focus. Let's see, center, focus, vertices, and co-vertices. Alright. So, for your focus, let's just say it is C. Okay? For your vertices, it is A. And your co-vertices is B. Alright? So, if your center is at the origin, it is 0 and 0. Now, if your vertices, isn't it that we said that vertices and focus always lies at their major axis. So, when we say major axis, it is also called as the principal axis. So therefore, when the major axis lies, or when your vertices and focuses lies on your major axis, so it means that is your principal axis. And you will notice that A is in your x-axis. Okay? So therefore, your principal axis is x. When your A is placed within the x, that is your principal axis. Okay? Or if you will notice, A is within the x. And your co-vertices, no? Co-vertices, which is B, lies in the y-axis. So it means this is our minor axis. Okay? So the formula, once again, is x squared over a squared plus y squared over b squared is equal to 1. Always remember is equal to 1. And how are we going to plot them? Because, of course, even though you have this formula already, how are you going to plot them? So, if you only have C, therefore, c squared is not allowed. If you only have a for vertices, of course, a squared is not allowed. So later on, we will going to we're going to identify, and we will be able to plot them. All right. So let's try for the first example. Let's have x squared over 25 plus y squared over 16 is equal to 1. All right. So we're going to define what is our center. Center is 0 and 0. So this is our center. Next, which is our vertex. Oh, let's say this is B. Our vertices, no, is A. So how are we going to plot our vertices? We said that when your vertices lies on the major axis, and we know that major axis is the longer one, so it means it has the highest value among the minor. So you could see that 25 is larger than 16, so therefore 25 is our major axis. Okay, so when this is our major axis already, okay, so therefore this is our A, because vertices is larger than co-vertices, isn't it? Okay po ha, so let's have the focus first. Focus is our C, and our co-vertices, let's put CV, it's our B. Okay, so our A squared is 25 ha. So if we have A squared and we have B squared, A squared is our 25. Let's just put in this manner. b squared. Our a squared is 25. And in order for us to get only the a, we are going to we are going to square both sides, or get the square root of both sides. Okay, so what's the square root of 25? The answer is 5. So it only says that a is equal to 5. Then, how about for b? B squared is equal to 16. 16. And in order for us to get the b, we are going to square, or get the square root of both sides. So in that case, b squared will become b, and the square root of 16 is simply as 4. Okay, so we now know the value for b. Okay? So, in plotting, we are going to focus first with the value of a, which is our vertices. It's a, isn't it? Okay, so how are we going to plot 5? How are you going to plot 5? Of course, if your principal axis is x, because it is larger in x, isn't it? It's in x. So therefore, if from your center, which is your center, 0 and 0, isn't it? 0 and 0. You are going to add and subtract 5. You're going to place the 5 in your x coordinate because it's the principal axis is at the x. So you are going to add, subtract 5. Distance of 5, ha? So in other cases, we just simply write it down as this, with this manner, ha? So it is positive and negative 5, then 0. So this is the formula, ha? Or the coordinates. So it will become positive, negative a, 0, or positive, negative 5, and 0. Okay, so now we have the coordinates for the vertices. How about the co-vertices? So our co-vertices is our minor, so therefore it's in y-intercept. Okay, so if it's y-intercept or y-axis, we are going to place it in this part of the coordinates. No? So, therefore, our x coordinate will be 0. And we are going to add 4, or our b. Add and subtract b. Okay, so our b now, or our coordinate now will be 0 and positive, negative 4. Okay, so in your c, how are you going to get c? Always remember that focus always lie at the major axis, and major axis our principal axis. Therefore, it also lies in x-axis as well. So you are going to add and subtract c. Okay? Then 0. Alright. So, we're going to add and subtract. What's the value of c? You don't have yet, isn't it? So, we are going to find what is the value of c. By how? This is the method, ha. C squared is equal to a squared minus b squared. So, in that case, how are you going to find c squared first? You're going to deal with this 2. Two givens. So we are going to square both, we are going to get the square root of both numbers. Okay, both numbers. And we are going to have c is equal to radical of a squared minus b squared. Or if that's the case, you're not going to separate a squared and b squared, ha? Okay, that's not the case. You're going to get a minus b, ha? That's not the case. So you're going to substitute first all the values of a squared and b squared. What's the value of a squared? The value is, what's the value of a squared? The value is 25. Correct. Minus, what's the value of 16? B squared. It is 16, isn't it? So if you're going to subtract this 2, The final answer will be 9. Square root, ha? Okay. So, what's the square root of 9? The square root of 9 is 3. So, therefore, we have the value of C already. So, our C is 3. So, therefore, we could add and subtract C. So, if you are going to plot this coordinates, let's plot this first, the A, your vertices. So you have positive and negative 5 for your x-intercept, ha? So from your x-intercept, this is your x-intercept, ha? Okay, so from your x-intercept, you have positive and negative 5 from your origin, ha? Because we base on the origin, 0, 0. You're going to add and subtract. Add 5, 1, 2, 3, 4, 5. So this is your vertex. And you're going to subtract 5. 1, 2, 3, 4, 5. This is your vertex. Okay, vertex still, ha. Okay. So, how about your focus? You're going to add and subtract 3 in your x-intercept. So, you're going to count 1, 2, 3. This is your focus. You're going to subtract 3. 1, 2, 3. Subtracting 3 and adding 3 coming from your center, ha. It's always in the center. Alright, so we have now the vertices and the foci. Now, what is your co-vertices? You have positive and negative 4, or you're going to add and subtract from your origin. No, so you're going to add 4. 1, 2, 3, 4. This is your co-vertices. And you're going to subtract 4 as well. 1, 2, 3, 4. So this is your co-vertices. Okay? Alright. So if we are going to graph it already, you have the ellipse just like that. Right? So this is your minor axis and this is your major axis. So this is when the principal axis is at x-axis, and you will notice that x-axis has the longer side. So it is the major axis. So therefore, all the principal axis is your major axis. Only that one. Alright. So next, I will be computing already. This next given. Next is when the principal axis is the y-axis. So if you will notice, so from the x, your b squared is the co-vertices. And the principal axis is y. Therefore, our major axis is y-intercept. Okay? So therefore, vertex lies on the major axis, isn't it? And major axis is our principal axis. So therefore, vertex or vertices lies on the major axis, and we could found it in our y-intercept. Okay? That's why letter A is within the y square. Okay? So, a while ago, we placed the value of A to your x-intercept coming from your center, isn't it? And your B, we're going to add and subtract. B, we're going to add and subtract B to your y-intercept. But this time, you are going to interchange it already. No? So, your you're going to add and subtract to your y-axis or y-intercept, and you're going to add and subtract B to your x-intercept. Same goes by with the focus. Our focus is our C, so therefore, we're going to add and subtract C. Now, refer us to plot the coordinate for C. Okay, so you're going to add and subtract the y-intercept. Okay, so let's try to have this example. So we have x squared over 100 plus y squared over 144 is equal to 1. Alright, so we are going to find the center. Center. This is the second case ha. Second case po, when the center of the ellipse is at the origin. So our center is the origin. So it is 0 and 0. So our vertices is at 0, positive, negative, A. Why is it at the y-axis? Because it's in the y-intercept. This is our principal axis, ha? So our focus also lies at the y-intercept. So 0, positive, negative, C. So our co-vertices lies at x-axis or x-intercept, ha? So therefore, we're going to add and subtract B. Alright, 0. So, what is our A value, and B value, and C value? So, A squared is 144. B squared is 100. So in order for us to get the A squared, we're going to get the radical of it. So, what is, take note ha, what is the square root of, what's the square root of 144? Well, the square root of 144 is 12, of course. So you're going to get 12 already. So we could write it down that A, the value of A is 12. Then we're going to get the square root of 100 as well in order for us to get the value of B ha. What's the square root of 100? The value of it is 10. So, in this case, we have the values of A and B already. So, in order for us to get the value of C, we're going to have the formula of C squared is equal to square root of A squared minus B squared. Okay? So, in that case, we're going to substitute all the values of A squared and B squared. What's the value of A squared? The value of it is 144. Then, minus B squared. What's B squared? It is 100. Okay. So, in that case, 144 minus 100, what's the value? It is 44. Of course, this radical still ha. So, alright. So, why do we need to square root this one already? Because the foundation of this formula is C squared is equal to A squared minus B squared. In order for us to get this C, we're going to get the radical of it, isn't it? So it will become C is equal to the radical of A squared minus B squared. Okay? So coming from this one, we have the value of C already. So it is radical or the square root of 44. Or in other words, if you want to find the factor of it, the factor of it is uh, square root of, let's try have this in this place, square root of 4 times 11, isn't it? So we could have here, what is the square root of 4? Is it is it a perfect square? Yes. So the square root of it is 2. Let's just put 2. Then you have the square root of 11. Could be that one. Okay, 11. So for for the coordinates of D or your vertices is 0, positive, negative. What is the value of your A? The value is 12. Positive, negative, 12. For your focus, it is 0, positive, negative, 2, square root of 11. Okay? 11, this one, 11. Then, for your B, you have what? Positive, negative of B. What's your B? It is 10. This is 10, ha? So, you're going to add and subtract 10 to your x intercept, then the 0. Okay, so this is your origin, or this is the center, no? It's the origin. Then finding what is your vertices. What are your vertices? It is 0. Then you're going to add and subtract 12. So coming from the origin, you're going to add, you're going to subtract. But is this, you're going to subtract. But this is my question. This is the one that we did a while ago. But are we going to add and subtract to your x-axis? No. We are not going to add and subtract to your x-axis for your vertices. Why? Because our principal axis by this time is y-axis. So therefore, we are going to add and subtract coming from your center to the y-intercept or y-axis. Okay? So therefore, your vertices is, we're going to add 12, ha? So let's assume that this part, let's assume that this part is the 12 already, ha? Positive 12, and I will be erasing this one. This is your negative 12 already. Okay, because the Cartesian thing is a bit small. Okay. Next, what is your focus? Your focus is positive and negative 2. And what? 2 and square root of 11. So if you're going to get square root of 11, what's the square root of 11? Square root of 11. Square root of 11. So it's 3.3166. 3.3166. Or, if you are going to have 44 a while ago, no? It's square root of 44. You could have 6 point something. Okay, so you had have 6.6332. Oh, why did it become 6.6332? Because you have 2 already, isn't it? So when you got the square root of 11, you will multiply it both. Okay, so 2 times this number. So your focus is located at 6.332. 6, you're going to add 6.332. Let's just say your focus is a bit here. Okay? So, don't be confused, ha. Your square root of, or the 2 square root of 11 is just equal with 44, ha. Oh, you could try to find what's the value of square root of 44, and the value is 6.332. Okay? Alright, so I hope that you are clear. Alright, so with that focus, you're going to add and subtract, of course. Subtract, you're going to have 6.332. So maybe your focus is a bit. Okay? So this is your focuses. How about for the co-vertices? So you are going to add and subtract 10. In what intercept or what axis? X-axis. No, because that is the coordinate that we have. Of course, co-vertices is perpendicular with the major axis. Minor axis is perpendicular with vertices. Ha. Okay, take note. So therefore, let's just say your co-vertices lies in here. So it's 10, negative 10, and positive 10. Okay. Oh, if you're going to plot it, it will become just like this. Okay. Alright, so we have the major axis or the principal axis, y. Okay, this is your minor axis. It seems like a 0, but the longer side in here is the 12. Correct? So that's how we graph when the center is at the origin. Okay? So how about when the center of your ellipse is at H and K? So it means the center of the ellipse is not in the origin. So it is somewhere around the parts of Cartesian plane. Maybe the first quadrant, second quadrant, third or fourth quadrant. Okay, so here's the formula, no? Formula of the ellipse when the principal axis is at the x-axis. So if you will notice, same goes by with the thing a while ago. No? So we have a below, or the denominator of your x is your A, or the vertices, because we said that distance of your vertices is larger, no, or longer than your co-vertices, no, or your minor axis. So therefore, this is your principal axis. And when the principal axis is y, this is our formula. Okay? Only that one, ha. I do hope that it is not really that kind of confusing. Okay? But let's try to have this uh, case a while ago. No? So let's have the example of x squared over 25. So let's have so that you have an example. Let's just have x over 25 plus y over 16. Let's have this in this part. X over 25 plus y over 16. We're going to subtract h, then square, isn't it? Alright. Then you are going to subtract k, then square. Then what if the values of VH, let's have the values in here is, let's just say 3, then 4. So, if you're going to ask me, what is the center? What's the center of your ellipse? The center is, what's the coordinates for the x-intercept? X is positive 3. Oh, you know how to get the intercepts, ha? Even though it is negative, the answer is positive. So when it's still in negative, the answer is positive. So your k is positive 4. But how about, what if your values, for example, let's just say it is positive 3 and positive 4. So therefore, your x and y coordinates are negative. Okay? Because the standard formula is x minus h and y minus k, isn't it? It's minus. So therefore, the values of h and k in there is positive. Okay? So let's try to have the negative, let's try to have the positive coordinates first. Okay? So let's have negative 3, negative 4. Alright, so same goes by. If our vertices is A, positive, negative A, our A in here is that 25 A squared. So A squared is 25. So our A is equal to 5. So it will become positive, negative 5, and 0. So our focus is C. So you're going to add and subtract as well as the x-axis. 0. So your C in here, what's your C a while ago? C squared. Let's just go back. Your C squared is 3. Your C is 3. So therefore, we're just referring for the first example also that we could have the axis. So this is CV is equal to positive, negative. Yeah. Alright, so our CV is 0 and positive, negative. B. Our B squared is 16. And our B is 4. Oh, how did we get 4? Here's how. For A squared, we get 5. It becomes 5 because we get the radical of it or the square of it. Okay? And same goes by with the value of B. So B is equal to 4. Okay? Same goes by with the C. C, we get the value of C coming from the formula of A squared minus B squared. So in that case, we're going to get the radical of each side. So in order for us to get the value of C, we're going to square this 1 and subtract 25 minus 16. So the value is radical of 9. And what's the square root of 9? It is 3. So we have the value of C, which is 3. So we are going to input 3 at the x-intercept as well. Why? Because it's in the principal axis is the x-intercept, okay, or x-axis, okay. So therefore, if we're going to plot, what is our center? 3 and 4, isn't it? So your x is 3, so you're going to count 3. 1, 2, 3, 3. And what is your 4? Going to count 4 up. 1, 2, 3, 4. So, your center, your center now is located at this part. So this is your center already. Don't be confused. For those students who are still confused in plotting the center. Now, if we have the center already, we can now proceed with the values of each coordinate. But there is a twist in this part because a while ago we just input the zeros, isn't it? When the center of your ellipse is at the origin, isn't it? So 0, 0 is the origin. Now, if the center of it is 4, so therefore it will become 4 and 4. And for your x-axis for the co-vertices is 3. Okay, 3. But Sir Jai, what will happen to the x-axis in your vertices and foci, and as well as with the co-vertices? So in this part, you're going to have these values. Okay, I'll be writing it down. So, coming from your center, what is your center? It's 3. So, you're going to add 5 and subtract 5. You're going to add and subtract 5, then 4. Okay? Alright. So, what's your focus here? Your center is 3. You're going to add and subtract 3. Then 4. Okay? Now, what is your co-vertices? It is 3, x-intercept. Then what is your y-intercept? 4. But you're going to add 4 as well. Add and subtract 4. Okay? So therefore, you have the values for B. What's the value of B? B is equal to 3 plus 5. The answer is 8. 8. Then you are going to subtract 5 as well. So, in plotting, let's just erase this first. No. So, in plotting, it seems like your V is H plus or minus A 0. When the principal axis is x-axis, and their focus is equal to H plus and minus C then 0. Then your co-vertices is 0. Not 0, I'm sorry. It's K. Because it's H and K, isn't it? our center is h, then k. So this is k, the value of k, then this is h, then you're going to add and subtract b. Okay, so from your h and k, you're going to add and subtract. Oh, you have 3, you're going to count 3 coming from your center. What is your principal axis? It's x. So you're going to add and subtract to the x-intercept. So in this part, we're going to add 3 first. Count 3, 1, 2, 3. But you're going to add 5 and subtract 5. So, coming from your 3, you're going to add 5. 1, 2, 3, 4, 5. Or let's just say your point is in here. Your point is in here. Alright. Then, you're going to have this way. Let's just say. You're going to have the vertices. I'm sorry, with this one. 3 plus 5, the answer is 8. So, this is your vertices. Okay. Then, 3 minus 5, the answer is negative 2. So, this is your vertices. Okay, so let's check if the distance is just the same. So, if you're going to count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So, they are correct. Or you are going to add and subtract 5 with it. So, in that case, that is our vertices. Okay? Sige po. How about for the focus? So, you are coming from the 3 ha. This is the 3. You are going to add 3. So, 3 plus 3, the answer is 6. So, it's in here. The x is 6. Then the 4 is y. So, this is your focus. How about 3 minus 3? It's 0. So, 0 and 4. So, this is your focus or foci, and this is your vertex. Now, what is your co-vertices? It's 3, coming from 3 ha. This is your 3. Then, I'll just change the color. It's 3 and what? 3, this is the 3 ha. 3. Then, up above 4. 4. Then you are going to add 4. 4 plus 4, it will become 8. So, your co-vertices is this in here. Okay? And you're going to subtract 4. So, coming from 4, the center, going to subtract 4. So, your co-vertices, the other co-vertices is at this side. Okay? So, therefore, if you're going to graph them already, you're going to have the graph of this part. Okay? So, this is our ellipse. So, this is our minor axis. And this is our major axis. These are the foci. These are the vertices. This is our center, and this is our co-vertices. Okay? Gets already? So I do hope that you understand it already. So for the y-axis, when the principal axis is the y-axis, that is just the same. No, so we're just going to transfer or interchange the places or placement of the A's, B's, and C's. Okay, so I do hope that you already know and try to remember and recall what are the parts of our ellipse. And with that said, I do hope that with this lesson, you were able to cope up for what are the things that you need to understand for your connect section ellipse. Okay, so with that, I'd like to thank you once again, grade 10, for watching this video, and let us see each other for the coming recorded video. Alright, so thank you. God bless. Return. See you next video. Bye.